There's a place in this universe where if you cross one invisible line, you are gone forever. Not dead, not lost, gone, in a way that even time itself cannot recover. We are going there today, and to understand what that really means, we first need to leave Earth entirely. We begin at the very top of the world, the geographic North Pole, 90 degrees north. A place so extreme that every single direction you can point is south. There is no east, there is no west, just south in every way you turn. And above you, the sky is alive. Curtains of green and violet light ripple and fold across the darkness, like something breathing, the Aurora Borealis. Charged particles hurled from the sun, spiraling down invisible magnetic field lines and igniting the atmosphere into this silent, breathtaking fire. Every human civilization that ever looked north at night saw this. The Vikings thought it was the reflection of shields carried by warrior goddesses riding across the sky. Indigenous peoples of the Arctic called it the dancing spirits of the dead. Others named it the fires of heaven. Thousands of years of wonder, thousands of different names, all pointed at the same phenomenon. And that tells you something profound about us as a species. We have always looked up and felt that something enormous was happening just beyond our understanding. Tonight, we're going to chase that feeling to its absolute limit. We are leaving Earth, not in a metaphor, not in a simulation. We are departing this planet, cutting through the upper atmosphere, punching past the thermosphere, and heading into the deep black of interstellar space. As we go, we aim our trajectory directly at the plane of the Milky Way, toward a region that astronomers have given a quietly ominous name, the zone of avoidance. This is the dense band of dust and gas that sits along the galactic equator, so thick that it blocks the light of entire galaxies behind it. As we pass through, you can almost feel it, the interstellar medium rushing past like fog on a highway at midnight. Particles that have drifted here for millions of years, unbothered, unobserved. Then we are through, and we turn around. Behind us, receding at impossible speed, is the Milky Way. And I want you to take a second with this, because it doesn't matter how many times you have seen a galaxy rendered in a documentary. Seeing your own home from the outside hits differently. That flat, luminous disk spinning slowly in the dark, threaded with dust lanes and lit from within by 400 billion stars. That is where every human being who ever lived was born, loved someone, died, built something, or looked up at the sky and wondered. From out here, it is the most beautiful thing in the universe, not because it is the biggest or the brightest, but because it is ours. Ahead of us now is the void, intergalactic space. A darkness so complete and so vast that most people never really grasp it. The distance we need to cover to reach our destination is approximately 450 million light-years. Let that sit for a moment. 1 light-year is about 6 trillion miles. We are talking about 450 million of those. We accelerate, hundreds of millions of times faster than light, and even at this speed, the scale of what surrounds us is staggering. Our destination is a system cataloged as ARP-272, also known as NGC 6050, a remarkable structure embedded in the Hercules Galaxy Cluster. The Hercules Cluster is part of something called the Great Wall, one of the largest known structures in the observable universe, a vast cosmic web of galaxy clusters and superclusters, stretching across hundreds of millions of light-years. And those bright points you are seeing out there as we travel, those are not stars. Each one of those pinpoints of light is an entire galaxy, tens to hundreds of thousands of light-years across, containing billions of suns. Each of those suns potentially orbited by worlds, and there are thousands of them visible in any given patch of sky. But here's something I need to tell you as we travel through this space, because it changes everything about how you understand what you are looking at. What you can see, the stars, the nebulae, the glowing gas clouds, every photon of light crossing this void. All of that visible matter adds up to roughly 5% of the total mass and energy in the universe. 5%. The rest? We cannot see it. We cannot touch it. We cannot detect it with any instrument we have built so far. And yet, we know it is there, because without it, none of this would exist. Galaxies rotate too fast for their visible mass alone. Light bends at angles that can only be explained by additional mass we cannot account for. Cosmic structures formed too quickly after the Big Bang for ordinary matter to have clumped together on its own. We call this invisible presence dark matter. And right now, as we fly through intergalactic space at incomprehensible speed, we are cutting through an enormous hidden web of it, a vast scaffolding that stretches across a universe like the skeleton underneath everything we can see. Dark matter does not shine. It does not emit radiation. It does not interact with light at all. It simply exists, pulling, holding, structuring. It is the silent architect of the cosmos, and we are passing through it right now without even being able to confirm exactly what it is. Ahead, something is beginning to resolve out of the darkness. At first, it is barely anything, a faint smudge, a slight thickening of the dark, the kind of thing your eye might dismiss as noise. But as we close in, it grows, it spreads, and what becomes clear is that this is not insignificant at all. What looked like nothing from hundreds of millions of light years away is, up close, one of the most violent and spectacular events the universe produces. NGC 6050 is not one galaxy. It is three. Three enormous spiral galaxies locked together in a slow-motion gravitational catastrophe. Each of them spans tens of thousands of light years. Each of them contains hundreds of billions of stars, planetary systems, moons, and unknown worlds we will never catalog. And they're colliding. Not crashing together in the way you might imagine. This is not a sudden impact. Galaxy collisions happen over timescales so vast they are almost impossible to imagine. Millions of years of gravitational interaction slowly warping each galaxy's shape, stretching spiral arms like pulled taffy, drawing streams of stars between them, distorting their internal structure until what was once three distinct beautiful spirals is gradually reshaped into something entirely new. And here's a strange and slightly unsettling thing about galaxy collisions. Even though we are talking about the merger of hundreds of billions of stars, almost none of them will actually collide with each other. Galaxies are mostly empty space. The distances between individual stars are so enormous that even when two entire galaxies pass through each other, the stars themselves slip past like ghosts. What changes is gravity, trajectory shift. Orbits are disrupted. Stars that spent billions of years in quiet elliptical paths are suddenly flung into chaotic new ones. The galaxy's structure changes, but the individual pieces survive. Except at the center. At the heart of almost every large galaxy sits a supermassive black hole. Not the stellar mass black holes that form when individual stars collapse. Those are typically a few times the mass of our sun. Supermassive black holes are something else entirely. Millions of times the mass of our sun. Sometimes billions. They sit at galactic centers like kings, shaping the movement of everything around them, feeding on gas and stars that drift too close, occasionally erupting in jets of energy that blast across millions of light years. And when two galaxies collide, their central black holes do not stay apart. Over time, over millions and millions of years, they spiral toward each other, driven closer by the gravitational chaos of the merger. Eventually, they merge too, releasing more energy and gravitational waves than the combined light output of billions of stars. We are approaching one of these objects now. The gravitational influence begins to make itself known before we are anywhere near the surface. Space itself starts to behave differently. Light from distant galaxies bends around us, arcing into curved streaks and rings. This is gravitational lensing, the warping of space-time by an object so massive that even the path light travels is redirected. The universe around us is beginning to smear and distort, a visual reminder that space is not just a backdrop, but a fabric, and something ahead of us is pulling that fabric inward with terrifying force. Time starts to behave strangely too. The closer you get to a supermassive black hole, the more time dilation takes hold. To someone watching us from a safe distance, we would appear to be slowing down, moving in slower and slower motion, our signal stretching out, our image dimming. From our perspective inside, everything continues normally. This is one of the most disorienting things relativity tells us, that time is not a constant. It bends, it stretches, it runs faster or slower depending on where you are in a gravitational field. And right now, we are entering a region where the difference between our time and the rest of the universe's time is becoming extreme. Ahead of us is a boundary, not a surface, not a wall. There is nothing physically there to see or touch, but it is the most consequential line in the universe, the event horizon, the point of no return. Inside this boundary, the escape velocity, the speed you would need to reach to break free from the gravitational pull, exceeds the speed of light. And since nothing we know of can travel faster than light, nothing that crosses this boundary can ever leave. Not light, not radiation, not information of any kind. To the outside universe, we effectively cease to exist at this moment. Our image freezes at the event horizon, slowly fading forever. We never appear to cross, but we have, and from inside, the descent continues. What lies beyond this point is a region of physics that our best theories can describe only partially. The mathematics of general relativity that we use to describe black holes breaks down at a singularity, a point where density becomes infinite, where our equations stop producing meaningful answers. Whether a true singularity exists, whether something more exotic waits at the center, whether information that falls in is somehow preserved or destroyed, these are questions that remain genuinely open. Not because scientists have not thought hard enough, but because this is one of those rare places where the universe has not yet given us the tools to see clearly. We began this journey with one invisible line, the one we warned you about at the very start, the point of no return. And now we have crossed it, 450 million light years from home, inside a collision of galaxies, past the edge of what physics can fully explain. The void, the dark matter web, the warping of space-time, 3 galaxies tearing each other apart. That is the universe we actually live in, not the small, comfortable version, the real one. Enormous and mostly invisible and stranger than anything we would have invented on our own. If that kind of scale and strangeness is what you are here for, there is another journey waiting for you, one that takes you even deeper into the physics of what happens when matter reaches its absolute limit. Go watch it. The universe does not run out of things to show you.